Welcome to this explainer. Okay, we're going to just dive right into it today because we are looking at something incredibly close to home. I mean, it is literally right next to your ear or sitting right there on your desk at this very moment. We're exploring the physics of sound, specifically how loudspeakers work. We're going to pull back the curtain on the absolutely fascinating, entirely invisible physics happening inside the very device you're using to listen to me right now. It's a process we totally take for granted, but as you'll see, it's basically scientific magic. Let's get into it.
I want you to pause for just a second and really think about this. How is your device creating the sound you're hearing right now? My voice started as digital data, right? Just ones and zeros hanging out on a server somewhere. But what is the exact physical mechanism that translates that data into the actual physical audible sounds currently hitting your eardrums? It isn't just software. There is a highly precise physical mechanical action happening inside your phone or computer right this very second. So, the master key to this whole puzzle is a brilliant principle of physics known as electromagnetism. Basically, it's the science of turning electricity into magnetism. Everything you hear from a speaker ultimately relies on this one foundational rule. We're essentially taking electrical currents and using them to create, and more importantly, to control, magnetic fields. It's a surprisingly elegant concept, and honestly, it's what makes all modern audio possible. To understand how that principle actually comes to life, let's mentally dismantle your speaker and look at its cast of characters. Every single speaker, no matter its size, shape, or how much it costs, contains three main components. First, you've got a fixed, permanent magnet. Second, there's a mobile voice coil, which, well, it's really just a cylinder wrapped super tightly in copper wire. And third, a flexible cone or diaphragm. What's absolutely wild to me is that this flexible cone is usually made out of the most everyday materials you can imagine. We're talking paper, plastic, or thin metal. That's the whole shebang. Just some copper wire, a standard magnet, and a bit of paper are responsible for every podcast, every hit song, and every soaring movie score you have ever heard in your entire life. Okay, so how do those three incredibly simple parts actually talk to each other to make music? Well, the journey begins the exact microsecond you press play on a song or a video on your device. The instant you do that, your device sends an electrical audio signal straight down the wire and directly into that second component we just talked about, the voice coil. Now, it's absolutely crucial to realize it's not sending actual sound down the wire. Actually, scratch that. It's more like it's sending an electrical current that perfectly represents the sound. So, let's look at the dynamic right at the heart of the speaker. On one side of this setup, we have our permanent magnet. It is completely stationary, totally fixed in place, and its magnetic field, it never changes. But on the other side, we have our voice coil. As that electric current from your device flows through the copper wire, it instantly transforms that simple coil into a temporary electromagnet. But here is the true genius part of the design. The magnetic field of this newly formed temporary electromagnet isn't static. It changes rapidly, expanding and contracting, matching the exact rhythm, pitch, and volume of the sound signal being sent from your device. Because this temporary electromagnet is sitting right next to our stationary permanent magnet, the two magnetic fields interact instantly. Think about what happens when you play with two standard magnets, right? They instantly react to one another. Because our temporary electromagnet's field is constantly shifting and flipping based on the audio signal, it rapidly alternates between attracting and repelling against the fixed magnet. Depending on the exact direction of the electricity at any given microsecond, those magnets are either violently pushing each other away or aggressively pulling each other closer. And this brings us to the sheer incredible speed of this violent magnetic dance. Because that audio signal is constantly fluctuating to recreate incredibly complex sounds, like, say, a human voice or a full symphony orchestra, this push and pull interaction causes the voice coil to vibrate back and forth at unbelievable speeds. We're talking up to thousands of times per second. Just imagine that for a moment. Right now, inside your device, a tiny copper cylinder is vibrating thousands of times every single second, just so you can hear the exact syllables of the words I'm saying right now. It's kind of hard to even wrap your head around that level of speed, isn't it? But here's the thing, a vibrating coil sitting all by itself doesn't make a sound we can actually hear. We have to shift our focus to the macro world to see the final piece of the puzzle, and that is the physical connection. You see, that vibrating voice coil is physically attached to the speaker cone, that everyday paper, plastic, or metal piece we mentioned earlier. Because they're glued or tightly fastened together, when the coil violently moves back and forth thousands of times a second, it has no choice but to force the much larger cone to violently move right along with it. Let's review this rapid-fire kinetic chain reaction from start to finish because it happens so fast. Step 1. The electrical signal from your device causes the temporary and permanent magnets to instantly interact. Step 2. That magnetic interaction makes the voice coil vibrate. Step 3. Because the coil is firmly attached to the cone vibrates along with it, violently pushing and pulling the surrounding air. And finally, Step 4. Those rapid movements of the cone create literal pressure waves in the air itself, which then physically travel across the room to your ears as the sound waves you ultimately hear. If you want to remember how this entire chain of complex physics works, just keep this one brilliant summary from our source material in mind. Quote, electrical signals shake a magnet, which shakes the air, creating sound. It's just a beautifully simple summary of a highly complex physical process. We take electricity, we turn it into magnetic motion, we use that motion to literally punch the air, and then your incredibly complex brain interprets that vibrating air as music or dialogue or sound effects. So, as we wrap up this explainer, I want to leave you with this final thought. What other hidden physics are happening around you right now? We just uncovered the invisible, high-speed magnetic dance happening inside a simple speaker. It really makes you wonder about the scientific wonders seamlessly integrated into everything else we touch every single day. Look around your room right now. What else is secretly performing incredible feats of physics just beneath the surface? Keep observing, keep questioning, and I really hope this sparked your curiosity to learn more.